This lesson goes over multivariable systems or linear systems and solving them. What we're going to be looking at today is just using back substitution with these linear systems. If you realize with these, they're a little bit different than what we're used to because now we are working with three variables. We have an x, a y, and a z. You'll see up here, when you give your answer, you're going to give it as an ordered triple. Instead of an ordered pair, we're working with ordered triples now. So it'll be x, comma, y, comma, z. With these, they're the easiest type to do because you already have one of the variables solved for. So the only thing you'd have to do is to take what that variable is equal to and plug it into one of those equations in order to solve for the next variable. Once you have what two of those three variables are equal to, plug them all into the equation that includes all three of those variables and solve for your last one. Then you write your answer as an ordered triple as parentheses x, comma, y, comma, z, close parentheses. So if we look at example 1, we have x minus 2y plus 3z is equal to 9, y plus 4z is equal to 7, and z is equal to 2. You see here that I underlined this 2 and I put an arrow to where that z is being multiplied by the 4 in the equation y plus 4z is equal to 7. The reason why I plug it into that equation is because that's an equation that only has two of these variables, not all three. So it's easiest to solve for the y in that equation because you just have a y and a z within the equation. So we're going to plug that 2 in for z in y plus 4 times z, which is 2, is equal to 7. The 4 times 2 is 8, so y plus 8 is equal to 7. We're going to subtract 8 from each side, and we get that y is equal to negative 1. Now that we have z and y, plug your z and your y into that top equation and solve for x. So x minus 2y, which is negative 1, plus 3z, which is 2, is equal to 9. We're going to have x plus 2 plus 6 is equal to 9. The 2 plus 6 is 8, so x plus 8 is equal to 9. We move the 8 over by subtracting it from each side, and we get that x is equal to 1. So now we have an x, a y, and a z. So our solution for this is the ordered triple of 1, negative 1, and 2. In order to check your answer, which is a good thing to do with all of these, plug them in to each of these equations. If you plugged in the 1 for x, the negative 1 for y, and the 2 for z, on the top equation, you get 9 is equal to 9. If you plug in the the negative 1 and the 2 in that middle equation, you get 7, which 7 is equal to 7. And then z is equal to 2 would just be 2 is equal to 2. So it makes true statements for all three of these equations. You know your answer is correct. For our next example, we're just showing that the ordered triple is a solution. So it gives us 1, 0, 2. That 1 is our x, the y is our 0, and the z is 2. So we're going to plug these in for each of these equations and see if they give us true statements. So we're going to start with the top equation, that x minus 3y plus z is equal to 3. We're going to plug in the 1 for x, the 0 for y, and the 2 for z, and simplify. 1 minus 3 times 0 is 1 minus 0, plus 2 is 3 is equal to 3. This works. Check your next one. The next one we have is 2x plus y minus 5z is equal to negative 8. Again, our x is 1, so that's 2 times 1, plus y, which is 0, minus 5 times z, which is 2, should equal negative 8. 2 times 1 is 2, plus 0, minus 10, should equal negative 8. The 2 minus 10 is negative 8. That gives us negative 8 is equal to negative 8, which is a true statement as well. So that one works also. Our final equation, we have x minus y plus 3z is equal to 7. So our x we said is 1, minus y, which is 0, plus 3 times 2 is equal to 7. This gives us 1 plus 6, which is also 7, is equal to 7. So again, we have a true statement for that one as well. So we know that the order triple 1, 0, 2 is a solution. The next example we're going to look at is 2x minus y plus 5z is equal to 24, y plus 2z is equal to 6, and z is equal to 8. So we're going to start this one by taking that z is equal to 8 and plugging it in for z in that middle equation so that way we can solve for y. So this is going to give us y plus 2 times 8 is equal to 6. This simplifies to be y plus 16 is equal to 6. We move the 16 over by subtracting it from each side, and we get that y is equal to negative 10. From here, we're going to take this y as well as this z and plug it in for y and z in that top equation. So this is going to give us 2x minus y, which is negative 10, plus 5 times z, which is 8, is equal to 24. We're going to simplify this one. Those two negatives become positive, so we have 2x plus 10, and 5 times 8 is 40, is equal to 24. From here, we're going to combine the 10 and the 40, so that gives us 2x plus 50 is equal to 24. From here, we're going to just subtract each side with that 50 in order to get that 2x by itself. So we're going to do the 24 minus 50, which gives us a negative 26. So that's 2x is equal to negative 26. We divide each side by the 2, and we get that x is equal to negative 13. So we have our three variables, our x, our y, and our z. We have that x is negative 13, y is negative 10, and z is 8. If you plug these in and check them for all, they work. They give you on the top 24 is equal to 24, 6 is equal to 6 for that middle, and 8 is equal to 8. So you have your order triple that is your answer. That is negative 13, negative 10, 8. So when you are working with these equations where you're given three different equations with three different variables, you do have certain steps that you need to follow. It's, to me, a lot easier to show to you as we're doing them rather than just telling them to you. So if we look at this example, the three equations that were given are x minus 2y plus 3z is equal to 9, negative x plus 3y plus z is equal to negative 2, and 2x minus 5y plus 5z is equal to 17. First thing you're going to want to do is you are going to want to take 2 out of the 3 equations and eliminate one of those variables. So in this case, we're going to take the first 2 equations, the x minus 2y plus 3z is equal to 9, as well as the negative x plus 3y plus z is equal to negative 2. We can eliminate those x values if we add these two. So those x's are going to cancel out. You have negative 2y plus 3y is y. Then 3z plus z is 4z. And 9 minus 2 is 7. So you have y plus 4z is equal to 7. From here, you are going to take one of the equations that you've already worked with and the other equation that you have not worked with yet, and do the same thing and eliminate the x values so that way you just have a y and a z. So if we choose the first equation, which is the x minus 2y plus 3z is equal to 9, and 2x minus 5y plus 5z is equal to 17, we can eliminate those x's if we multiply the top equation by negative 2. So this is going to give us negative 2x plus 4y minus 6z is equal to negative 18, as well as 2x minus 5y plus 5z is equal to 17. If we add these two, our x values are eliminated. We have 4y minus 5y, which is negative y. Negative 6z plus 5z is negative z. And negative 18 plus 17 is negative 1. So from here, we have two equations where we both have a y and a z within them. So you're going to use those two in order to solve for the z to get now a third equation. So you're going to work with one of these two equations as well as one of the original equations. You can work with this top equation if you'd like to, and then let's say we want to work with this equation, we can do that as well. So again, you're going to take the two equations that you have here, so the y plus 4z is equal to 7, and the negative y minus z is equal to negative 1. And you are going to eliminate your y values and solve for that z. So you're going to just combine these. Your y's are going to cancel out. You have 4z minus z is 3z, and 7 minus 1 is 6. Now you can use this, or you can solve for the z and use what z is equal to. If you were to solve for z, or if you were just to leave it, either way, you can still solve for z later on. You are going to now use one of the top equations from the first set of 3, which is, like we said, we're going to use x minus 2y plus 3z is equal to 9. One of the y and z equations, so I chose to use the y plus 4z is equal to 7. And then we can use the 3z is equal to 6 as well. Now you have a system that looks similar to the previous systems that we've done within this lesson, to where you can solve for z, plug that z into the y plus 4z is equal to 7, solve for y. You then have y and z, plug it into the top equation, solve for x, and you'll have all three variables and what they're equal to. So if we were to take that 3z is equal to 6 and solve it, we're going to divide each side by the 3, and you get that z is equal to 2. You are then going to take the 2 and and plug that into the y plus 4z is equal to 7. So we're going to take that 2, plug it in. We have y plus 4 times 2 is equal to 7. The 2 times 4 is 8. We're going to move the 8 over by subtracting it from each side, and you get that y is negative 1. From here, you have y and you have z. Solve for x. Use that top equation, plug both of them in. So you have x minus 2 times y, which is negative 1, plus 3 times z, which is 2, is equal to 9. The negative 2 times negative 1 is positive 2. 3 times 2 is 6. We combine the... So from here, you're going to have x plus 8 is equal to 9. You move the 8 over by subtracting it from each side, and you get that x is equal to 1. So then your solution here, you're going to write as the order triple of the x, comma, y, comma, z. So it's 1, negative 1, 2. For this example, we have 2x plus y plus 3z is equal to 9, x minus 2y plus z is equal to 8, and negative 4x plus 3y plus 2z is equal to negative 4. I'm going to start by using the 2x plus y plus 3z is equal to 9, and the x minus 2y plus z is equal to 8. I'm going to multiply the bottom equation by negative 2, so that way my x values cancel out. We're going to have 2x plus y plus 3z is equal to 9, and negative 2x plus 4y minus 2z is equal to negative 16. We're going to combine these. Our x values cancel. We have 5y plus z is equal to negative 7. Now I'm going to use one of the two top equations that I already used and that bottom equation from the original system. So I'm going to use the 2x plus y plus 3z is equal to 9, and the negative 4x plus 3y plus 2z is equal to negative 4. So from here, I'm going to multiply the top equation by 2, so So again, my x values will cancel. We have 4x plus 2y plus 6z is equal to 18, and negative 4x plus 3y plus 2z is equal to negative 4. We combine these, those x values cancel. We have 5y plus 8z is equal to 14. So I'm going to choose that middle equation. I'm also going to choose the 5y plus z is equal to negative 7. And then I'm going to also solve for z using these two equations that I have that are just y and z. So I have 5y plus z is equal to negative 7, and 5y plus 8z is equal to 14. I'm going to distribute a negative into the bottom here. So we have 5y plus z is equal to negative 7, and negative 5y minus 8z is equal to negative 14. This is going to give us negative 7z is equal to negative 21. We're going to divide each side by the negative 7, and we get that z is 3. So the system that we're working with in order to solve is going to be x minus 2y plus z is equal to 8, 5y plus z is equal to negative 7, and z is equal to 3. So we're going to first plug in the 3 for z, and that 5y plus 3 is equal to negative 7. We move the 3 over by subtracting it. We get 5y is equal to negative 10. Divide each side by the 5. So y is negative 2. We then take the z that is 3 and the y that's negative 2, plug it in to solve for x in the top equation. So we're going to have x minus 2y, which is negative 2, plus z, which is 3, is equal to 8. From here, we're going to have x plus 4 plus 3 is equal to 8. So x plus 7 is equal to 8. We move the 7 over, subtract it from each side. We have that x is equal to 1. So for our ordered triple, we have 1, comma, negative 2, comma, 3. For this example, we have x plus y plus 3z is equal to 7. 2x minus 4y is equal to z is, 2x minus 4y plus z is equal to 7. 3x plus 5y minus 4z is equal to negative 6. I'm going to use the first two equations to begin with to eliminate my x value from there. So we're going to work with x plus y plus 3z is equal to 7, and 2x minus 4y plus z is equal to 7. If we distribute in a negative 2 to the top, we're going to have negative 2x minus 2y minus 6z is equal to negative 14, as well as the bottom, which is 2x minus 4y plus z is equal to 7. So we're going to combine those. Those x's cancel out. Negative 2y minus 4y is negative 6y. Negative 6z plus z is negative 5z. And negative 14 plus 7 is negative 7. So from here, use one of the two top equations that you just worked with, as well as the last equation. So I'm going to use the top, which is x plus y plus 3z is equal to 7, as well as 3x plus 5y minus 4z is equal to negative 6. The top equation, I'm going to multiply everything by a negative 3. So it's going to give us negative 3x minus 3y minus 9z is equal to negative 21, as well as 3x plus 5y minus 4z is equal to negative 6. Again, we're combining. Those x's cancel. Negative 3 plus 5 is 2y. Negative 9 plus 4 is negative 9 minus 4 is negative 13z. And negative 21 minus 6 is negative 27. So we have these two equations that we're going to use to eliminate the y values from. So we have negative 6y minus 5z is equal to negative 7. as well as 2y minus 13z is equal to negative 27. We are going to multiply the bottom equation by 3 in order to cancel out those y's. The top one is not going to change. The bottom you're going to make into 6y minus 39z is equal to negative 27 times 3 is negative 81. So you are going to combine these to eliminate those y values. You have negative 39 minus 5 gives us negative 44z is equal to negative 7 minus 81 is negative 88. We're going to divide each side by the negative 44. And we get that z is positive 2. So you're going to make a new system. We're going to use one of the original. I'm going to use the top one. We're going to use one of the y and the z. I'm going to use the 2y minus 3z is equal to negative 27. We're going to use that z is equal to 2. So we're going to just rewrite this as x plus y plus 3z is equal to 7. 2y minus 13z is equal to negative 27. And z is equal to 2. Using that z is equal to 2, I'm going to plug that in and solve for y. And 2y minus 13z is equal to negative 27. So this is going to give us 2y minus 13 times 2 is equal to negative 27. So 2y minus 26 is equal to negative 27. We add the 26 to both sides. We get 2y is equal to negative 1. Divide each side by the 2. And y is negative 1/2. Plug in the negative 1/2. Plug in the 2. Solve for x. So x plus negative 1/2 plus 3 times 2 is equal to 7. This is going to give us x minus 1/2 plus 6 is equal to 7. The 1/2 plus 6, the 6 becomes 12 over 2. So this is x plus 11 over 2 is equal to 7, or 14 over 2. We're going to subtract 11 over 2 from each side. We get x is equal to 3 over 2. So our ordered triple here for this one is 3 over 2, negative 1/2, 2. For your last example, we're given x minus 3y plus z is equal to 1, 2x minus y minus 2z is equal to 2, and x plus 2y minus 3z is equal to negative 1. I'm going to just start by using the first two equations. So x minus 3y plus z is equal to 1, and 2x minus y minus 2z is equal to 2. We're going to multiply the top equation by negative 2 so we can cancel out those x's. We have negative 2x plus 6y minus 2z is equal to negative 2. And 2x minus y minus 2z is equal to 2. We're going to combine these to get rid of those x values. We have 5y minus 4z is equal to 0. We're then going to use one of the two equations that we already worked with. I'm going to choose the top one. So x minus 3y plus z is equal to 1. And that bottom equation, since we haven't worked with it yet, so x plus 2y minus 3z is equal to negative 1. I'm just going to subtract these. So this is going to give us x minus 3y minus z is equal to 1. And negative x minus 2y plus 3z is equal to 1. We combine our two equations. Those x's are going to cancel. We have negative 5y plus 2z is equal to 2. I'm then going to use both of these equations. So 5y minus 4z is equal to 0. And negative 5y plus 2z is equal to 2. We're going to combine these. Since our y values are already opposites, they cancel out. We have negative 2z is equal to 2. We can divide each side by the negative 2. And we get that z is negative 1. From here, I'm going to use the z is equal to -1, the 5y minus 4z is equal to 0, and the x minus 3y plus z is equal to 1 in our new system. From here, we are going to plug in that -1 in for z in that in the y and the z equation. So we're going to have 5y minus 4 times -1 is equal to 0. This gives us 5y plus 4 is equal to 0. Move your 4 over, subtract it from each side. You have 5y is equal to -4. Divide each side by the 5. And you have that y is equal to -4/5. From here, plug that in, solve for x. So we're going to have x minus 3 times -4/5 plus z, which is -1, is equal to 1. This is going to leave us with x plus 12 over 5 minus 5 over 5 is equal to 5 over 5. From here, we're going to have x plus 7 over 5 is equal to 5 over 5. We subtract the 7 over 5 from each side and get that x is equal to -2/5. So this is giving us an order triple of -2/5, -4/5, and -1. However, if we plug these values in and simplify, we're going to have -2/5. I'm going to just go into the original system and plug them in. Minus 3 times -4/5 plus -1. That gives us 1, so that's a true statement. Next we have 2 times -2/5 minus -4/5 minus 2 times -1. It gives us 2, so that middle one is right, or gives us a true statement also. Then the bottom one, we have x, which is -2/5 plus 2 times -4/5 minus 3 times -1 gives us 1, not -1. So because that bottom one is the only one that doesn't work, it makes the entire thing have no solution. So this top one works, this middle one works, but the bottom one doesn't. So again, we have no solution.